So here we have to sum up a series given, okay, that is function of n, right? So we'll try to generalize this one and try to get an expression for fn and then try to find the limit of this one, right? So fn, if I try to generalize and simplify, so this is n plus, now you see every term here, this is 16, 32, 48. So every time there is an increase of 16, right? So let's say this is the first term. This is our first term. Let this be like n only. Okay? Leave it there like n. This be my first term. So that is r is equal to 1. Okay. So r is the iterator. I will write 16r. Okay. For r is equal to 1, this is just 16. Okay. Plus, now the second term here is 5n, then minus 3n. So that means there is a decrease of 4n every time, right? So 5, then 1, then minus 3, there is a decrease of 4 every time. So that is an AP, right? So the second thing here, this thing I'll write as n times, first term is 5 plus r minus 1 times the common difference is minus 4, right? So this is how I generalize the second term here, okay? And this is minus 3n square everywhere. So this is just minus 3n square, okay? Upon, now this is see 4n, 8n, 14n. So every time there is an increase of 4n, right? So I will write this thing as 4rn, right? R is equal to 1, this is 4n, r is equal to 2, this is 8n, and likewise. Plus this thing here is 3n square everywhere, right? So I will write this thing as simply fn I can write as sigma of this expression here, okay, while r goes from 1 to n, right? Now this is what I have to simplify, fine. So on simplification I am going to get this is equal to, so this thing here, just see, is 16r plus n times, that is 5 minus 4r plus 4 minus 3n square upon, here I can take n as common, so 4r plus 3n in the denominator, okay? And this is the same as 16r plus 9n minus 4nr minus 3n square upon times 4r plus 3n, okay? So this thing here has simplified to this, right? And this I can further write as 16r plus 9n upon n times 4r plus 3n minus n times 4r plus 3n upon n times 4r plus 3n. So this is simply 1, right? This is simply 1, okay? So in a simplified way, I can write this fn whole thing is equal to what? So this fn here I can write as, there was one n here, this n plus sigma of this minus 1, right? So sigma of 16r plus 9n upon n times 4r plus 3n minus 1, okay? R goes from 1 to n, right? Okay, now we see this is what? This is simply n plus sigma of 16r plus 9n upon n times 4r plus 3n minus sigma 1. Okay, sigma 1 is simply n only, right? This thing will be n, sigma of 1. So this n here and this n cancels out. I am left with only this thing. Sigma r is equal to 1 to n, 16r plus 9n upon n times 4r plus 3n here. Okay, that means fn is equal to sigma of r is equal to 1 to n, 16r plus 9n upon n times 4r plus 3n, right? Now to simplify this one, I'll use integration as a limit of sum. What I can do here, so for the technique of doing that is, we create this thing. we create r upon n, and r upon n I replace by x, okay, and 1 upon x I replace by dx, right? So let's create this thing here. This is the same as sigma. I'll take one n common from the numerator. So this is 16 times r upon n plus 9 upon, again I'll take one n from the denominator also as common. So this is 4 r upon n plus 3 here. Okay. Now you see, I told that r upon x we have to replace by x, 1 upon n I have to replace by dx, okay, to convert this as a integration as a limit of sum, okay. So this will be, this n cancels this one, so I am left with this 1 upon n here. So this is the same as integral 16 r upon n here, I'll replace by x. So 16x plus 9 upon 4, again here r upon n is 4x plus 3, and I was left with this 1 upon n here, that is dx, okay. And what is the limit? So just see, the limit of r was 1 to n, right? So when r is 1, initially this is 1 upon n, r upon n is 1 upon n, and 1 upon n for a very large n will tend towards 0. So x is starting from 0, and when r is equal to n, this becomes n upon n, that is 1, okay. When r becomes equal to n, x becomes 1. So the limit is from 0 to 1, right? So ultimately I have to just evaluate this integral now. Fine. So this I can write as integral of 0 to 1 and 16x plus 12 minus 3 upon 4x plus 3 dx. Okay. So this is integral of 4 minus 3 upon 4x plus 3 dx, 0 to 1, okay. That is 4x minus 3 ln 4x plus 3 upon 4, right? The limit is from 0 to 1 here, right? So this is going to be 4 minus 3 by 4 ln, for 1 it is going to be ln 7, and for 0 it is going to be 3. So ln 7 upon 3, right? So this here becomes the final expression, final answer, 4 minus 3 by 4 ln 7 by 3. That is option number B. So option B here becomes the answer. Okay. Thank you.